Hi, students and friends. This is your host and teacher Syed Ayazuddin Heather. So, this is the video session for the topical for the syllabus code 5070 and 0620. And I have selected chemical energetics. So, I've covered selected questions for this topic from the year 2023. It's covering both summer and winter. So let's start the paper. Here's question number 1. This question is about the energy changes that take place during chemical reactions. A. Methane reacts with chlorine to make chloromethane. The reaction is exothermic. Draw on the axis provided in figure 1.1 the reaction pathway diagram for this reaction. Include labels for the axis, reactants, products, enthalpy change of reaction delta H, activation energy EA. Total mark for this question is 5. So first of all, I have to show the axis. So on x-axis, what do you have? You can have time, or reaction pathway. You can even write reaction coordinate on x-axis. On y-axis, you have temperature, that is energy change for energy. Temperature in centigrade for energy. No axes are done. But they are saying show reactants. What reactants you are having? It's the reaction between CH4 and Cl2. The products are CH3Cl plus HCl. So this line will be of reactants. Straight line of for reactants. And the reaction is exothermic. They have already mentioned in the question. So the product must be at the low energy state. So this line is of product. Now I am writing the symbol equation for reactants and product. So we have CH4 gas plus Cl2 gas. Product we have CH3 Cl gas plus HCl gas. Now next thing they are saying enthalpy change of reaction delta H. Enthalpy change of reaction delta H must be between reactant and product. So it must be between reactant and product. This must be delta H. And as this reaction is exothermic, the sign must be minus. Last thing, but not the least, it's activation energy. So activation energy, you have to show the hump, energy hump. It will be like this. So it must be along the line of reactant. This is activation energy EA, and it's always positive. Moving to next question. Question number 1, part B. Hydrogen iodide decomposes to make hydrogen and iodine. This is the reaction equation. 2HI gives H bond H plus I bond I. Calculate the enthalpy change of this reaction. Use the bond energies in table 1.1. Here's table 1.1. Bond energies are given for H bond H, I bond I, H bond I. Now they are saying enthalpy change of this reaction. Recall the formula for the enthalpy change of reaction. Energy released or associated with bond breaking. The formula will be like this. Delta H is equal to energy released or associated with bond breaking minus, sorry, there's a mistake, not energy release, energy required. It's not energy release, it's energy required. So you write energy needed during bond breaking. Then you subtract it, energy released during bond making. Energy minus energy released during bond making. So we have two HI bonds. So I will multiply 2 by 298. It will be like this. Putting all these things in bracket. Minus, we have H bond H, which is 436. Plus I bond I is 151. Now let's solve this. 2 multiplied by 298. $596. 596 minus 436 plus 151. 587. So 596 minus 596 minus 587. So answer is plus 9. So I will write plus 9 here. For this question. Now for question number 2, this question is about the energy changes that take place during chemical reaction. Part A, nitrogen reacts with oxygen to make nitrogen monoxide. The reaction is endothermic. There is a reaction N2 gas plus O2 gas gives 2NO gas. Draw on the axis provided in figure 2.1 the reaction pathway diagram for this reaction. Include labels for the axis, reactants, product, enthalpy change of reaction delta H, activation energy EA. So on x-axis you have time or reaction pathway, and on y-axis you have temperature in centigrade. So you have reactants. The reaction is, let's see this again. Reaction is endothermic, which means the product will be at high energy state than the reactant. So this is the reactant. So this must be the product. And the energy will be like this. And this will be the activation energy for this reaction. EA is equal to plus. For enthalpy change should be between reactant and products. Reactant and product, this will be the enthalpy change, and the sign must be plus. Now what is left? Reactants and product. We have N2 plus O2 gives 2NO. So we have reactant N2 gas plus O2 gas gives 2NO gas. So this will be the final energy profile diagram or reaction pathway diagram for this reaction. Now next part is about enthalpy change. Hydrogen reacts with bromine to make hydrogen bromide. We have H bond H plus Br bond Br gives 2HBr. Calculate the enthalpy change for this reaction. Use the bond energies in table 2.1. Again, I've just told you the formula for enthalpy change. And that is energy needed during bond breaking minus energy released during bond making. So we have H bond H and Br bond Br bond Br. So H bond H must be 436 plus Br bond Br 193 minus energy release with the making of bond between Br and H, that is 366, but should be multiplied by 2. There are 2 moles of HBr. So 436 plus 193. $629 minus 2 multiplied by 366 multiplied by 366, 732. So 629 minus 732 minus 103. So minus 103 will be the answer for this question. This must be in kilojoule per moles. Question number 3. Chemical reactions can involve transfer of thermal energy. Number 1, state the term used for the transfer of thermal energy during a reaction. Call it enthalpy change of reaction. We'll write enthalpy change of reaction. Part 2. Figure 3.1 shows an incomplete reaction pathway diagram for the forward reaction. This reaction, CCl4G plus 2H2OG, reversible sign, CO2G plus 4HClG. On figure 3.1, insert the formula of the reactants and products. So on the reactant side, we have CCl4G plus 2H2OL. And on the product side, we have CO2G plus 4HClG. Draw an arrow labeled EA to show the activation energy. So this will be the activation energy. We'll be starting from the reactant side. The line should be straight from the reactant, and this will be the EA. It must be plus. Activation energy of EA is also always having a plus sign. Draw an arrow labeled delta H to show the transfer of energy in this reaction. So the delta H is enthalpy change. It must be between reactants and product, and this is the delta H for this reaction. And it is in this case They didn't provide us any information related to whether the reaction is exothermic or endothermic. So you will only write delta H. Moving to next question. Define the term activation energy. So it's the minimum energy that colliding particles must have to react. So you write minimum energy. Colliding particles must have colliding particles must have to react. Number 4. State one way in which the activation energy of a reaction can be changed. Now you can decrease activation energy by adding catalyst. So you write decreased by adding a catalyst. Moving to next question, that's part 5. The equation for the reaction between tetrachloromethane gas and steam can be represented as shown in figure 3.2. With the reaction, this is between tetrachloromethane and water. Steam is water to produce carbon dioxide and HCl. The sign indicates the exothermic reaction. I will write exothermic. Table 3.1 shows some bond energies. Here's table 3.1. Use the bond energies in table 3.1 and the delta H value for the reaction to calculate HCl bond energy using the following steps. So first of all, you need to calculate the energy needed to break the bonds in the reactants. So on the reactant side, we have 4 CCl bond. That's 1, 2, 3, 4. So I will write 4 and it will be multiplied by the bond energy of CCl. Where is it? CCl is here, 340. Plus, we have 4 OH bond or HO bond. 1, 2, 3, 4. So I will multiply 4 by his HO bond. HO or OH bond have same meaning, 460. So 4 multiplied by 340. 1360 plus now 4 multiplied by 460. 1840. So adding up these two, 1360 plus 1840, we will get 3200 kilojoule. So I will write 3200 here. Now calculate the energy released when the bonds in carbon dioxide form. Energy released when carbon dioxide form. So we have how many bonds of C double bond O? We have 1, 2. So you will multiply 2 by 805. 2 should be multiplied by 805. 2 multiplied by 805. 1610. So I will write 1610. Calculate the HCl bond energy. So here is the formula. Follow this formula. Enthalpy change is equal to energy needed in bond breaking minus energy released in bond making. Now putting the values, enthalpy change is provided in this question, and that is minus 130. Minus 130. So you will start with minus 130 is equal to energy change or energy needed in bond breaking. It's 3200 minus energy released when bonds are made, and only that energy which is provided to us is of carbon dioxide. When the bonds in carbon dioxide form, the energy is 1610. We need to calculate the HCl bond energy. And if you will look at this question, I mean the reaction equation, there are 4 HCl bonds. 1, 2, 3, 4. So let's consider HCl bond as X. So I will write 4X. Plus 4X. Opening the equation, or if you want, you can readjust this equation. So you'll get minus 130 plus 3200. Sorry, minus 3200. As I shifted 3200 from right hand side to left hand side is equal to minus 1610 minus 4X, or 4X is equal to minus 130 minus 3200 plus 1610. Let's solve this. 1610 minus 130 minus 3200 minus 1720. It must be minus 4s. Minus 4x is equal to minus 1720, or so as both the side contains minus sign, this will be cancelled out or become plus. So we'll have x is equal to 1720 divided by 4. And we will get 430. So plus 430 will be the final answer. This will be the bond energy associated with HCl. Moving to next question. The forward reaction in the Haber process is exothermic. Explain in terms of bond making and bond breaking why this reaction is exothermic. So whenever you are solving these kind of questions, you will always start with these statements. These are common statements. These are common statements. Bond breaking is endothermic. Bond breaking is endothermic. Or you can even write bond breaking needs energy, or bond breaking needs energy. The other statement will be related to bond making. Bond making is exothermic. Bond making is exothermic. Or you can even write bond making gives energy out, or bond making gives energy out. Don't write outside the line. I'm solving, that's why I'm actually giving more than one statement. So that's why I'm writing outside the line, but stay in the line. Write your statements in the line provided to you. The last statement, it must be associated with this exothermic. So you will write what? More energy is released than absorbed. You can even write the reverse statement, less energy is absorbed than release. So I'm writing only one statement. More energy is released. More energy is released than absorbed. Part 2. The transfer of thermal energy in a chemical reaction is called the enthalpy change. Write this symbol for enthalpy change. Include the sign for an exothermic enthalpy change. Enthalpy change is represented by delta H, and for exothermic reaction, it's always minus. So I will write minus. Question number 5. Steam reacts with carbon to produce carbon monoxide and hydrogen. The forward reaction is endothermic. This time they are saying, they gave us the question for endothermic. Number 1, explain in terms of bond making and bond breaking why this reaction is endothermic. Coming back to this question, we have these statements will be common. These two statements will be common for this question number 5, part 1. Only the last statement, this one, this statement will be changed. So now I will write down the statement. Bond breaking is endothermic. Bond making is exothermic. Now, in this reaction, we have endothermic. So what you will write? You will write more energy is absorbed than released. You can even write less energy is released than absorbed. I am writing the statements, both these statements. More energy is absorbed than released. Or the other statement, if you want, you can write this statement, less energy is released than absorbed. Last question. The transfer of thermal energy in a chemical reaction is called the enthalpy change. Write the symbol for enthalpy change. Include the sign for an endothermic enthalpy change. So you have delta H, and the sign for endothermic must be plus. You can write the answer in this way also, plus delta H. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.